We've learned what an additive identity is, and we learned how in a matrix, it's just a bunch of zeros in your matrix. You put a bunch of zeros in there, and if you add it, it's not going to change your answer. This video is going to talk about the multiplicative identity. What can you multiply by so your answer doesn't change? And the super logical thing that really everybody I've seen will try the first time they encounter this question is they'll put a little matrix here with ones in it. I mean, if you put all zeros and it doesn't change your answer, like why not be all ones for multiplying? If you try this though, and you actually do the karate chop here, I'm going to have a 1 landing on a 1, which is 1, and then 1 lands on 2, which is 2. 1 plus 2, that should be a 3 right up there. The karate chop process does not work with this matrix right here. I mean, it doesn't give you this answer if you multiply them. If we were to multiply straight across, it'd be great, but that's not how multiplying works. So unfortunately, this wasn't the answer. The actual answer that's going to be what we want to multiply by is a matrix that has ones on, it starts in the top left, has ones on the diagonal like this, and everywhere else in the matrix is a 0. So in a 2 by 2 is just 1, 0, 0, 1 like this. This is called the identity matrix for multiplication. And the letter we usually use for that is a capital I. So you'll sometimes see I equals this matrix right here. And I want to show real fast, if you verify with the karate chops, with the first one here, I'm just going to get 1, and then a 2 times 0 is 0, which is just 1. 3, and then the 0 kills off the 4, I just get a 3. 0 kills off the 1, so I just get 1 times 2, which is 2. And then 0 kills off the 3, I just get 4 times 1, which is 4. So if you multiply those, it works out. So, oops, on this problem here, I need to add on the 5, 6. Otherwise, you wouldn't be able to multiply those. So, what can I multiply this guy by to get this answer right here? Well, this is a 3 by 2, and I want to get, so I have 3 by 2 times don't know, but I know I'm supposed to get a 3 by 2. So the middle numbers have to match, otherwise I can't even do the problem. So I know it has to be a 2 by something, otherwise I'm wasting my time. I can't even do the problem. And I want my answer to be a 3 by 2, so this answer has to be a 2 as well. So I actually need a 2 by 2 matrix right here. And it turns out it's the same exact one. If you multiply by the identity matrix here and you verify in the karate chops, you will get this answer. So that's my identity right there. The only difference with the identity matrix, it's always going to be a square matrix, but if you have a bigger one like this guy, I have a 3 by 3, and I don't know what the second one is, but I know I'm supposed to get a 3 by 3. This has to be a 3, otherwise I can't even do the problem. And this will have to be a 3 on the outside to get me a 3 by 3. So when you have a 3 by 3 matrix, the only difference is that your identity has ones on the diagonal still. Everywhere else is a 0. So when you're making an identity matrix, they are always squares. You can't have a rectangular, like a 2 by 1 identity. And they've got ones on the main diagonal. Everywhere else is 0. If you'd like to practice and make sure you verify that this answer works in the last one, please do so.